Hello everyone, I am Ritika Zuzgar, Assistant Professor IT Department. So in the course of Artificial Intelligence, we discuss about Unit 3. So Unit 3 is based on knowledge representation and reasoning, where we already discuss about the concept of knowledge representation and reasoning also. Okay. So in this video we are going to discuss about the conditional probability and the Bayes theorem. So let us discuss here. So first thing is conditional probability. So it is the probability of occurring an event when another event has already happened. So let us suppose we want to calculate the event A when event B has already occurred. Okay, we have to calculate the probability of event A when event B is already occurred. So the probability of A under the condition of B, so it can be written as like this. So probability of A bar B is equal to probability of A and B divided by probability of B. Okay. So where probability of A and B is called as a joint probability of A and B, capital A and capital B, and probability of B is a marginal probability of B. Okay, so in the next part we will discuss about what is meant by joint probability and marginal probability. So here we only discuss about the conditional probability. For what purpose? Suppose we have to calculate the event A and the event B is already occurred. Okay, find out the event A where the already occurred event is what B. So the probability of A and B divided by probability of B. So here if the probability of A is given and we need to find the probability of B, then it will be given as, okay, so we have to find out the probability of B. So here probability of B bar A is equal to probability of A and B divided by probability of A. So it can be explained by using this Venn diagram where B is occurred event. So the sample space will be reduced to set B, and now we can only calculate the event A when event B is already occurred. We have to calculate the event A when event B is already occurred. So by dividing the probability of, by using this formula, probability of A bar B is equal to probability of A and B divided by probability of B, and this is a simple Venn diagram. So see here, there is one example. So in a class there are 70% of students who like English and 40% of students who likes English and mathematics. Okay, 70% are students who likes English and 40% of students who likes English and mathematics. Then what is the percent of student those who like English also and like mathematics also? Okay, so this is our example. So solution is, let A is an event that a student likes mathematics, okay, and B is an event that a student like English. Okay, A for mathematics, B for English. So we have to find out the probability of A bar B who likes English also and like mathematics. So probability of A and B divided by probability of B. Okay, so the probability of A and B, that means the 40% of student who likes English also and mathematics also, so this is a 0.4, and probability of B, that means the 70% of students like English, 0.7, is equal to 57%. Okay, if we are calculating this, we get the 57%. Okay, that means the 57 are students who likes English also like mathematics. Okay, so this is a conditional probability. So the next thing is a Bayes theorem. So Bayes theorem is also known as a Bayes rules, Bayes law, or Bayesian reasoning, which determine the probability of an event with the uncertain knowledge. So in the probability theory, it relates the conditional probability and marginal probability of two random events. So the Bayes theorem was named after the British mathematician Thomas Bayes, and the Bayes interface is an application of Bayes theorem, which is a fundamental to the Bayesian statistics. So it is a way to calculate the value of probability of probability of B bar A with the knowledge of probability of A bar B. Okay. So this Bayes theorem allows the updating the probability prediction of an event by observing the new information of the real world. Okay. So see here, there is another example. If the cancer corresponds to the one age, then by using the Bayes theorem, we can determine the probability of cancer more accurately with the help of age. So here we can use the Bayes theorem, and it can be derived using the product rule and the conditional probability of event A with the known event B. Okay. So as from product rule, we can write So Bayes theorem can be derived using the product rule and the conditional probability of event A with the known event B. Okay, so as from product rule, we can write it as the probability of A and B is equal to probability of A bar B into probability of B. Okay, or simply we can write it as for a probability of event B with the known event A. Okay, so probability of A and B is equal to probability of B bar A into probability of A. So we are equating the right hand side of the both the equations. Okay, right hand side of the both the equations. So we will get the probability of A bar B, okay, is equal to probability of B bar A into the probability of A divided by probability of B by equating the right hand side of these two equations. Okay. So we are assigning this is our equation number 1. Okay, so this is our equation number 1. So in this equation, it is called as a Bayes rule or Bayes theorem. So this equation is the basic of most modern artificial intelligence system for the probabilistic interface, okay, or the probabilistic inferences. Okay, so we can use this type Bayes theorem formula in the artificial intelligence for artificial intelligence system for probabilistic inferences. So it shows the simple relationship between joint and conditional probability. Okay, we already discussed about the conditional probability here. So this is called as a conditional probability. So this is a combination of conditional probability and the joint probability. So here the probability of A bar B is known as a posterior probability, which we need to calculate, and it will be read as a probability of hypothesis A when we have occurred and evidence B. Okay, we can read it as a probability of hypothesis A when we have the occurred and evidence B. Then the second thing is the probability of B bar A. Okay, so here we are using the probability of B bar A, which is called as a likelihood. So in which we consider the hypothesis is a true, then we calculate the probability of evidence. Okay, then next is the probability of A. It is called as a prior probability. So this is a probability of hypothesis before considering the evidence. Okay, before considering the evidence. And probability of B is what here? It is called as a marginal probability. Okay, so here it is called as a marginal probability. So what is mean by this? So probability of marginal probability is a pure probability of an evidence. It is a pure probability of an evidence. So in the equation A, in general, we can write it as the probability of B is equal to the probability of A into the probability of B bar AI. Okay, so hence the Bayes rule can be written as for probability of A of I bar B is equal to the probability of A of I into the probability of B bar A of I divided by summation of I is equal to 1 to k the probability of A of j into the probability of B into A of Z. Okay, so this is a Bayes rule. So the next thing is, so here the A of I means what here? A1, A2, A3 and A of N. It is the mutual exclusive and the exclusive events. Okay, mutual exclusive events. Because here A and B are what here? Events, and A of I is what? Mutual exclusive and the exhaustive events. So next thing is applying the Bayes rule. So Bayes rule allow us to compute the single term probability of B bar A in terms of probability of A bar B. So here the probability of B and the probability of A. So this is a very useful in cases where we have a good probability of these three terms and we want to determine the fourth one. Okay, so suppose we want to pursue the effect of some unknown cause, we have to pursue some effect from unknown causes and want to compute that causes. Then the Bayes rule becomes the probability of cause bar effect is equal to probability of effect bar cause into the probability of cause divided by probability of effect. Okay, so by using this type of formula we can applying the Bayes rule. So see here, there is one example. The question is, what is the probability that a patient has a disease meningitis with a stiff neck? So here we have a given data. Doctor is aware that the disease meningitis cause a patient to have a stiff neck, and it occurs the 80% of the time. So he is also aware of some more facts which are given as follows. So the facts are the known probability that a patient has a meningitis disease is 1 divided by 30,000. Okay, so this is the first fact. And the second fact is the known probability that a patient has a stiff neck is a 2%. So let A be the proposition that patient has a stiff neck, and B the proposition that patient has a meningitis. Okay, here we are using A and B. A is for the proposition that patient has a stiff neck, and B is the proposition that the patient has a meningitis. Okay, so we have to calculate the following as the probability of A bar B is equal to 0.8. Okay, probability of A bar B for the meningitis cause the patient to have a stiff neck and it occurs the 80%, that means 0.8. So probability of B, the patient has a meningitis disease. B is for meningitis and A is for the stiff neck. So probability that a patient has a meningitis disease is a 1 divided by 30,000. Okay, so this is another given data. And the probability of it, the probability that patient has a stiff neck, for the stiff neck we are using the A, that means the 0.02%. So we have to find out the probability that the patient has a meningitis with a stiff neck. That means we have to find out the probability of B bar A. Okay, so the formula is probability of A bar B into the probability of B divided by probability of A. We are putting all these values into this formula. That means 0.8 into 1 divided by 3000 divided by 0.02. So where we get this type of answer. So we can assume that the one patient out of the 750 patient has the meningitis disease with the stiff neck. Okay. So the another example is the question from a standard deck of playing card. The single card is a drawn. So the probability that the card is king is 4 divided by 52. Then calculate the posterior probability P of king bar face, which means the draw face card is a king card. So So we have to find out the P of king bar face is equal to, formula is probability of face bar king into the probability of king divided by probability of face. Okay, so this is the equation. So we have the probability of king is equal to probability of that the card is a king, that means 4 by 52, that means 1 divided by 30. The probability of face is what? The probability that card is a face card, that means 3 divided by 13. Okay, remaining cards. Then face bar king, probability of face card when we assume it taking the king is equal to 1. So putting all these values in this equation, we will get the probability of king bar face is equal to 1, that means the face king 1 into the king, that means 1 by 13 divided by 3 by 13. So here we get the 1 by 3. So it is a probability that the face card is a king card. Okay, face card is a king card. So this is another example by using the Bayes theorem. So next thing is what are the applications of Bayes theorem here. So it is used to calculate the next step of the robot when the already executed step is given. The Bayes theorem is helpful in weather forecasting, and it can be solved the Monty Hall problems. Okay, so we can use the weather forecast, we can use this Bayes theorem in weather forecasting type problems, Monty Hall type problems, and we can also use in the robot when the already execute the step is given. Okay, so these are the applications of Bayes theorem. So in the next lecture we will discuss about the Bayes network and the example of Bayes network. Thank you.